welcome back to my channel. Myself, Yojna Kumar. I am lecturer in chemical engineering of Tekewak Polytechnic, Nashik. Today I am going to discuss psychrometric chart with you from the topic psychrometry. And this topic comes under the subject plant utility of second year diploma in chemical engineering. What is psychrometry? Psychrometry is the science dealing with the physical laws of air, water, vapors, and the mixtures. By studying the psychrometry, we can understand the different thermodynamic properties related to the moist air. Presence of moisture and studying of the properties of that moist air is also known as psychrometry. When designing of an air conditioner, the temperature and the moisture content of the air to be conditioned and the same properties of the air needed to produce the desired air conditioning effect is necessary. In other words, we can say that psychrometry is the study of moist air or mixture of dry air and the water vapor. In this video, we will see the different properties of psychrometry like dew point temperature, relative humidity, humidity ratio, dry bulb temperature, wet bulb temperature, humidity, under that specific humidity, absolute humidity, and the psychrometric ratio. Now we will see one by one the different properties of moist air. Dew point. It is the temperature at which the moisture starts to condense out of the air is known as dew point. Means the temperature at which the first droplet of water is formed from the water vapor during the condensation process is known as dew point. Dew point is also known as saturation temperature. In this figure, I have shown one water droplet on the leaf surface. During the winter season, in the morning, we can see some water droplets are there on the leaf surfaces. It shows the condensation of the water vapors which is present in the atmosphere into the water droplet. Next is relative humidity. Relative humidity is always shown in the percentage form, and it is the ratio of amount of moisture that a given amount of air is holding to the amount of moisture that a given amount of air can hold. Next is humidity ratio. Humidity ratio is the amount of moisture per unit of dry air. It is denoted by W and it is equal to M by G. Next is dry bulb temperature. The dry bulb temperature is the temperature indicated by a thermometer exposed to the air in a place sheltered from direct solar radiation. The term dry bulb is customarily added to temperature to distinguish it from wet bulb and the dew point temperature. In a simple words, we can say the temperature which is measured by the normal thermometer is known as dry bulb temperature. Next is wet bulb temperature. Wet bulb temperature is the temperature recorded by thermometer when the bulb is enveloped by a cotton wick saturated with the water. The accuracy of a simple wet bulb thermometer depends on the how fast air passes over the bulb and how well the thermometer is shielded from the radiant temperature of its surrounding. In a simple words, what is wet bulb temperature? It is the temperature measured by a thermometer which is covered with the or which bulb is covered with the wetted wick is known as wet bulb temperature. In this diagram, you can see here the dry bulb temperature thermometer is shown and the wet bulb thermometer is shown. Here you can see it is a normal thermometer and here the bulb of this wet bulb thermometer is covered with the wetted wick. Next is specific humidity. Specific humidity is defined as the proportion of the mass of water vapor per unit mass of moist air sample. That is dry air plus the water vapor. It is closely related to the humidity ratio and always lower in value. And the absolute humidity is the mass of water vapor per unit volume of air containing the water vapor. Here you can see it is the ratio of mass upon volume. That's why we call it as water vapor density. Here you can see this is one psychrometric chart which I have shown in this video. In this psychrometric chart, various properties which we have seen earlier have been shown. In this, you can see this x-axis represent the dry bulb temperature, and the vertical lines of this dry bulb temperature are given in this psychrometric chart. Also, the lines which make 30-degree angle with the x-axis, and the scale of this line is shown on this last curve, and the scale shows the wet bulb or the saturation temperature. The horizontal lines here you can see are shown on this y-axis scale. It shows the moisture content kg per kg of dry air. And visually towards this line, here we will get the dew point temperature. And here this lines which make 30-degree angle with the x-axis, if we extend this line up to this scale, it will show the specific enthalpy at saturation kilojoule per kg of dry air. And the lines, you can see these are the lines which makes the 60-degree angle with the x-axis, shows the specific volume meter cube per kg of dry air. Now I will show you one by one that which line represent which property of the psychrometric. So here I have shown, you can see in this dry bulb temperature scale is shown on the x-axis. You can see the scale shows the dry bulb temperature scale, and the vertical lines in the psychrometric chart shows the dry bulb line, and the scale of this dry bulb line is taken from this x-axis. Next is wet bulb lines. Wet bulb lines makes 30-degree angle with the x-axis, and this inclined line shows the wet bulb lines, and the scale of these wet bulb lines is given on this last 100% humidity curve. Next is relative humidity line. This relative humidity lines are the curves in between the psychrometric charts. And all these relative humidity lines shows the percentage of the humidity, and it is shown in the psychrometric chart. You can see from 20% to from 0 to the 100%, this relative humidity curves are shown in the psychrometric chart. Next lines, horizontal lines, shows the humidity ratio. These horizontal lines are parallel to the x-axis, and the humidity ratio scale is given on the y-axis. This y-axis shows the scale of humidity ratio, and it is given in kg of moisture per kg of dry air. And the same horizontal lines also shows the dew point line, but the difference is that this dew point line scale is given on this 100% relative humidity curve. And remember that the dew point temperature scale and the wet bulb temperature scale, both the scales are given on this 100% humidity line. If you goes horizontally towards this 100% relative humidity curve, then you will get the value of wet bulb temperature, and which we have seen previously, that if you go horizontally to this y-axis, you will get the humidity ratio. So don't get confused between this. Again, I will tell you, if you go horizontally towards the y-axis, it will show the humidity ratio, and if you go horizontally towards the 100% relative humidity curve, you will get the dew point temperature. Next is specific enthalpy line. This specific enthalpy lines are same as the wet bulb temperature lines, but the difference is that if you extend this wet bulb temperature line towards the scale which is shown in the psychrometric chart, then you will get the specific enthalpy. Okay, remember that you need to extend this wet bulb temperature line, which makes 30-degree angle with the x-axis, towards this enthalpy scale, then you will get the specific enthalpy scale. So we will take one example of this psychrometric chart. Suppose you have given dry bulb temperature, that is 25 degrees Celsius, and the wet bulb temperature is 20 degrees Celsius, and you need to find out the relative humidity, then the dew point temperature, humidity ratio, volume, and the enthalpy. In this diagram, I have shown the reading which we got from this psychrometric chart. Firstly, we have given the dry bulb temperature 25 degrees Celsius. So we will draw a line, vertical line to this 25 degrees Celsius, and we know that the wet bulb temperature is 20 degrees Celsius, and these inclined lines which make the 30-degree angle with the x-axis shows this wet bulb temperature. So for the 20 degrees Celsius, you can see this black dotted line I have shown over here shows the wet bulb temperature. Now find out the intersect of these both the lines. Here the 20 degrees Celsius, 25 degrees Celsius, both get intersect, or here I will mark it as by red cross. Okay, now we will find out the different properties through this psychrometric chart. We know that the horizontal line which is passing through that intersect and which is parallel to the x-axis, and when we goes horizontally towards the y-axis, it shows the humidity ratio, which is in a moisture content kg per kg of dry air. So here from you can see this purple line shows the humidity ratio, and it is on the y-axis, it shows the scale of 0.126 kg per kg of dry air. We will convert it into the gram. So we will get the reading of 12.6 gram per kg. If we goes horizontally towards this 100% relative humidity curve, here we will get the dew point temperature, that is 17.6 degree Celsius. For finding out the specific enthalpy, I have told you this 30-degree angle line, this inclined line which makes the 30-degree angle with the x-axis, we need to extend it towards this scale, enthalpy scale. Okay, you can see this blue line shows now the enthalpy scale. Here, this point shows the enthalpy of our numerical, that is 57.5 kilojoule per kg. To find out the relative humidity, this curve shows the relative humidity in the percentage, in that this pink colored curve I have shown in this diagram. This shows the relative humidity for this numerical. I have drawn this diagram through this our intersect. Okay, and it is in between the 60 to 70%. It is near to 60%, so it is 60%. Okay, in this way we have find out enthalpy, then the dew point temperature, then the relative humidity, and also we have find out this humidity ratio in this psychrometric chart. I hope you have understand how we will find out the different thermodynamic properties of the moist air through this psychrometric chart. In this diagram, I have shown in a simple way which we have find out in that numerical. You can see we have find out this intersect, and through the intersect we drawn a line horizontally towards this curve, that is 17.6. We get this reading. Then horizontally towards the y-axis 12.6. We have got the reading of humidity ratio, and this blue line which shows the specific volume, and it is 0.86 meter cube per kg DA, and the line which extended in this 100% humidity curve towards this enthalpy scale, that is 57.5 kilojoule per kg. Thank you friends for watching my video. We will meet soon